AVB, the AVnu Alliance. This is the AVnu Alliance podcast. This is the AVnu Alliance podcast. This is the AVnu Alliance podcast, brought to you by the AVnu Alliance, the fine folks that are helping you get AVB. With us this time is Rick Kreifeldt he is the AVnu Alliance president and chair. How are you, sir?
I'm doing great.
Awesome. Also with us is Todd Walter from National Instruments. He is the senior group manager.
Hello.
Hello, sir.
Hi, Tim.
All right. And last but not least, from Cisco, Paul Didier is the solutions architect, IOE Vertical Solutions Group.
Hello.
All right. Here's what we're going to do this time. We've got some exciting things to talk about as far as AVB. One is here recently, the AVnu Alliance is announcing what they're calling the fourth pillar. Rick, real quickly before we get to that, before we get to that announcement, let's kind of go over what markets does the AVnu Alliance serve? What are the three main markets for AVB?
Right. So the three main markets that we started the alliance around were around the Pro AV market, and then also automotive, and then consumer electronics. That's where there's a lot of commonality around this AV streaming need. And then we built that up to quite a big group now. We've got 80 members. We've got the majority of the silicon makers. So this has been really going strong. And as the standards kept evolving, there's been this need for adding more real-time control. And a lot of the technology developed in AVB actually works perfectly for this, for automotive and other applications. So we started into this new technology. It's what AVB Gen 2 has become known as, which is TSN. And from that, there's a whole new market that we're expanding into, which is the industrial market.
All right, and that is the fourth pillar that we're going to talk about. Is that right?
Right.
All right, Todd. Real quickly, let's kick it off with you with NI. How does AVB work in the industrial?
Sure. So I guess I'll specify. I think what we're looking for is really more standard Ethernet. AVB is a part of it. TSN is a part of it. You can kind of ignore the acronyms, perhaps. What we're looking for is using standard Ethernet so that we can run converged systems that run both a closed-loop control as well as normal communication via web services or via file sharing to and from these devices. Now, there's been a lot of work over the years, a lot of different Ethernet variants to meet the needs of industrial control, and they've had to really be specialized because on normal unmodified Ethernet, historically, you have not been able to provide capabilities for latency bounding on messages, for bandwidth reservation, for reliability, and for synchronization, so I can have coordinated actions. Those are all three things that the changes to the standard that AVB started, that TSN is continuing, supplies those. And so we're expecting, as we get all these pieces into standard silicon, into standard infrastructure, that we will be able to run full control networks on this broad-based standard Ethernet.
So take me through, if someone's not familiar with the industrial market and they're looking at this transport and saying, okay, that this is something that has typically and traditionally been audio and video, the AVB bridging part, for Pro AV, for consumer electronics and automotive, but even in automotive they're primarily doing audio and video. How does the industrial market figure into this, and how does this help them?
Sure. I think let me give a brief background on a control application. And a control application, to use more audio-video style terminology, you have talkers and listeners, but instead of sending a continuous stream of data between them, what they're doing is they're sending small packets of data, but they're doing that at a fast rate. And so you may, at a 5 kilohertz or 5,000 times a second, need to be sending packets back and forth. and the delivery time of those packets is very important because I'm using that to actually do control operations. Perhaps it's to control an actuator that is moving a motion piece as part of an assembly or part of a machine. So the classic way that Ethernet was built, where you have lots of different traffic coming in, you don't know exactly what traffic will come in. It is really impossible to guarantee that I'm always going to get my packet within the bounded time that I need. What AVB did is it created some traffic classes, created time-aware capabilities. What TSN does on top of that is we use those time-aware capabilities in those traffic classes to schedule the packets between. And so now we have a class of traffic that is scheduled from the talker through the switches all the way to the listeners. And at the same time, we have other time when all of the rest of your traffic is running through the network. So I have a true converged system, but I have scheduled traffic for my control tasks that lets me actually validate my system design.
Okay. All right. Paul, one of the things about AVB is that it is a standard. It's, you guys, AVB uses IEEE standards a lot. What are some of the standards that we're using for this new industrial market segment?
So there's a whole new range of time-sensitive networking standards being developed on top of the AVB audio-visual bridging set. The time-sensitive networking enhancements in 802.1 are bringing in the scheduling capabilities, bringing in guaranteed packet delivery concepts and models, enhancing some of the timing and synchronization. So those we imagine are going to form the basis of for AVnu to adopt into their interoperability standards, and that's what the industrials are in particular very interested in. As Todd noted, to achieve those deterministic characteristics within a standard networking model, those are the technologies we're working with a lot of these industrials already in IEEE on, and AVNus can be an important part of making those widely available and interoperable.
So let me make sure I understand you correctly. Are you saying that there are some of these standards are able to guarantee packet delivery? Is that right?
We're looking at how to pass packets in a network. Multiple versions of the packet, pass it around the network, and to give a higher chance of delivery at the other end to achieve some of the availability requirements in these industrial networks. So we imagine, having multi-path networks out there and having this technology effectively use those to achieve much higher delivery rates than what's typically achievable in a standard Ethernet today.
No, that's
right.
Yeah,
So
that's
Tim,
very
if I can jump in on that point. So it's one of the neat things about how this happens with standards development and how this comes into AVnu is, what Paul was just talking about is the redundancy features where we can use multi-path networks. So this gives you a standards-based way of doing redundancy, which, obviously for industrial control, if you've got a big, huge robot arm moving, you want that thing to be highly reliable. It also benefits our other markets. So if you're thinking about, a stage setup and you're doing, live performance, or you're doing something like a life safety application, or also the automotive guys are looking to bring that in for doing Ethernet control for things like driverless cars. So you have an Ethernet backbone inside, and again, if your car is driving by itself, you probably would feel a lot better if it had redundant networks and was highly reliable, right?
Yeah, absolutely.
So it's again how these things, same technology, different market applications, and they get to leverage each other.
Oh, very good. Todd, you guys, you're heading up the new task force for the industrial. First of all, if someone's interested, a member of AVNu Alliance, if they're interested in being on this task force, how do they do so? Do they just kind of raise your hand or send you an email and say, hey, I'm interested, or how does that happen?
Google Live.
Yeah, first you can just sign up for the work group. We're happy for volunteers. If you are not yet a member of AVNu, obviously we invite you to join. We also, as part of the launch of the industrial pillar, we also have created this other group we call the Industrial Advisory Council. And so this is a way where you can learn more about what we're doing, learn more about the changes that are coming to the standards and to standard Ethernet. It also gives you a chance to give us some feedback if there are pieces that we're missing on the way you want to use redundancy or the way you want to do network configuration or have device communication. We welcome that input as well.
Very good. Rick, it's been an interesting year. It's been an exciting year for AVB and for the AVNu Alliance. Kicked off the year in February with your very first certified product. It was an Extreme Network switch. You've released a couple more, or not you guys have released, but there have been a couple of other certified products as well. So what from your standpoint, what does 2014 look like for AVNu Alliance?
Yeah, so for 2015, we've got quite a few things going on. Obviously, the industrial segment kicking off. We've got our automotive certification that'll open the middle of the year. Around the same time, we'll also open up our video broadcast, for broadcast. That segment will also open for certification. So we've got, multiple certifications opening, and we've got this new segment kicking off.
All right, you mentioned the video, the V and AVB. How is that going? What is the status of the video transport?
Yeah, the video, and again, it's a tale of different things in different markets. So this for the automotive market, that's part of their first certification program. So they didn't do a separate audio certification like the Pro market did, and so that's in there, and that's for mostly backup cameras and like surround view cameras. So that's ongoing work. And then the on the Pro video side, where you need to do all these, obviously higher formats and 4K video, all those kind of things. So that's moving along. We've got several people who have been developing solutions that are showing those off now and starting to do those into our plug fests. And so I'm feeling really good that we're going to get those products out and into the certification program here, this 2015.
And then you're still doing that at the video portion as well at the University of New Hampshire?
Right. Yeah, so U of H is still our primary certification partner, and we also have announced a new certification partner who's a secondary test house. They're called Ruitz. They are based in Germany, so they have a long background in the automotive space. So that gives us another test house. So we're starting to get some interest too for some Asian test houses. So it's likely in 2015 we'll end up with a test house in every major geography.
Oh, very good, very good. You've added a number of members this year. How many do you have now?
Yeah, we're up to 80 members now. So it's third straight year of over 20% growth in the Alliance as far as membership.
And what have been some of the more higher profile, I guess, is the best way to put this, members to come on board?
Yeah, I think, probably really worth noting are the new members that are coming on to form this industrial segment. So we've got National Instruments, obviously, with Todd. And we've got Hirschman, and we've got GE. So you've got some big players coming in from that industrial segment that are really adding a lot of power behind us.
Very good. You mentioned the automotive segment. That was one of the more interesting things of the last 12 months, 18 months. How is that process coming along?
That's going really well. We've got several more OEMs in the works for adding into the Alliance, and that overall roadmap there is super strong. It's going, and this is where, coming back to the industrial, there's so much synergy between them. We first started into these TSN technologies because the automotive market right away said we're going to go from this audio-video quickly into doing some of the active safety controls and things like that. And the basic AVV Gen 1 could fulfill the simple needs, but to get to really this drive-by-wire autonomous cars, you want to go to these more advanced features. And so there's a really nice roadmap through that where you end up with a handful of nodes in the car doing AV to all these nodes in the car doing all the the control side. So really big push going on there.
All right. Todd, Rick mentioned the TSN. These standards, are they ready like currently, or are they still in development?
My experience with standards bodies is they're always in development.
Yes.
It's always the next improvement we thought of. But no, so the what I'll call the core pieces that we need out of the TSN efforts are still in work. They are progressing well. They're in various states of draft. There are some vendors who are building pre-standard silicon. So there's some parts out there that we're getting experience on now. But the spec itself, or the specs, are still in work in the committees.
Yeah, but I think the important point of that, Tim, is the worst thing that you would have is actually standards work stopping on this.
Yeah.
So the fact that you've got a big group of companies in the IEEE and they're continuing to build on this technology, they're improving it, they're adding new capabilities, it gets us new markets. Think of if 802.11 had stopped at A, where would we be? And so instead of that, right, it just keeps on getting bigger, better, faster. And so that's the neat thing about being part of this, and it shows that there's a real, vibrant ecosystem around this and bringing this technology into more markets.
Yeah, absolutely. That's one thing that's, bigger, faster, Moore's Law and everything.
I think it also highlights, Rick, the need for AVNu, or the role of AVNu, as we do keep enabling different capabilities and new sets, agreeing on how we're going to use these base standards and how equipment will interoperate to make sure that as we add new pieces into the spec, that the way it's actually used, the way it's tested, the way devices work together doesn't break from one generation to the next. And so the conformance and the operability we're doing through AVNu are going to lay that foundation that we can keep adding better capabilities onto this without needing to worry about that we just broke the one we started with.
Well, Todd, that's actually a really good point. How do you do that? I mean, not to getting into the the engineering of it, but how do you maintain this leading edge mentality and continuing to push it forward while still holding on to the legacy products?
That's a great question. That's like the innovator's dilemma book, right? Of how do you juggle this constant need to replace the technology you're comfortable with one that's going to make it better. For us, we're looking at the Internet of Things and the lift that we are going to be able to get as an industry from being able to truly connect and communicate and break down these classical barriers of using proxies and using some of these proprietary lower level buses. That brings huge value with the ability now to do data analytics, remote management, remote servicing. Those pieces, those value props are high enough that we want to go through and replace ourselves. And then you end up in a decision of, as you're doing those replacements, coming up with the style of those touch points and the right options for customers on those touch points that they can choose when they're going to keep their brownfield installs working and augment with new tech, and where they're going to go with new tech. And we just want to make sure that there's a good continuity, at least right now. And then as you go forward from there, you can build on that.
Yeah, absolutely.
Yeah, and from an alliance standpoint, Tim, I can't think of a single networking technology that's widely deployed that hasn't gone through this. In fact, maybe it's a sign of it. So if you think of USB to USB 2, USB 3, Bluetooth, we're up to 4.
Yeah.
Wi-Fi, obviously, all the things in the Wi-Fi alliance. So you almost can look back and say it's probably a sign that this thing is going to live and breathe, that there's been multiple generations. And so for AVnu, we've got a lot of experienced people within the alliance coming from different companies. I mean, take Cisco, for example, who've done this in other alliances. And so they understand, dealing with these technology changes, and we'll follow best practices from other alliances and make sure we do it.
Yeah. Paul, Todd mentioned the Internet of Things. Your title, IOE, is Internet of Everything. Cisco has gone beyond the Internet of Things, Internet of Everything. How does this figure in, the Internet of Things, with not just the industrial segment of AVB, this fourth pillar, but this whole interconnected thing? How does Cisco and just the Internet of Things in general fit in?
So when we talk about the Internet of Everything, what we would say is part of the big innovation is the Internet of Things coming into this established world of the Internet, where you have people processing data, all communicating and working over Internet technologies. Well, the new thing is the things. We're bringing in a wave of new devices, of new data, and that's going to provide a huge potential to the rest of the Internet, to companies overall. I think we've estimated in the range of 18 billion or $18 trillion over 10 years of value for the world in terms of this Internet of Everything, but mostly driven by the Internet of Things coming into this play. Much of that value is going to be driven out of industrials, where connectivity, better connectivity to the things, the robots, the machines, the cars, the trains, the pumps. All of this connectivity to these devices and rich data coming back is going to allow us to optimize and improve how equipment effectiveness, equipment uptime, energy utilization, wastage, all of these things. And this, as Todd was referring, this ability to converge a lot of that rich, low-level sensor control actuation traffic is going to be a big, powerful part of this increase of data. To be able to analyze that in algorithms, big algorithms, cloud, or smaller algorithms in the fog close to those real-time physical systems is going to enable us to do some really wonderful things. That's where we, adding it all up, come up to the trillions of dollars.
Paul, actually, real quickly before I let you go, this is a different this new, I guess, iteration where we're going after the industrial. Is this similar silicone from what we're used to in the past, or is this new a new version of silicone that we're dealing with?
I think silicon is continuously improving.
Okay.
Over time. We're adding new features and functions. We constantly see that. So I think, yes, there's going to be some enhancements from silicon on up, also software and other kind of mechanisms. So the silicon is just kind of like one perspective of it all, but we'll see some of these mechanisms use existing silicon. We'll see some advancements in the silicon to improve the timing, to improve the latencies and the jitters, and the real-time operating systems they'll be enhanced too. So I see this as just one of many technological advancements, including using a lot of impact in the silicon as well.
Okay, very good. Todd, from your perspective and your standpoint, who should be on the AVnu Alliance? Who should join you either in the industrial pillar group or just the AVnu group in general?
Sure. Well, I'll try to respond for industrial first, and
okay.
may lean on others to help with the other market spaces. What we have seen is that industry has been wanting to go to standard cabling, standard infrastructure for years. A decade ago, we largely moved as an industry from serial buses to Ethernet-based buses, but to achieve the level of performance and reliability, often had to modify various aspects of the system design, whether that was the hardware or whether that was restricting what devices were on and carefully engineering all of the traffic. So there's been a strong desire to have these kinds of capabilities. I believe, and I believe others working on IEEE standards and on the implementation of these, believe that the industry is going to go through another of these changes. And if we look back a decade from now, we'll see this as one of those transition periods. So who should be interested in that? Well, we've kind of said it's really three different groups that we think will want to get ahead of it. One is obviously there are vendors, either vendors who are building the industrial measurement control equipment, or vendors who are building the network infrastructure. So those are guys like National Instruments, GE, Cisco, and that's why you're seeing us participate. There's a set of companies that have invested in creating the network protocols that exist on this, and so whether that's OPC or others, they're groups that certainly have interest and have the ability to build on top of this foundation that we're creating to move those protocols to the next generation. And then the third group that, as I've been speaking with individuals in the market, larger end users and smaller, who have on board technologists. They have on board folks who are trying to figure out how they're going to build their next generation of machine or the next generation of equipment. And they really benefit from seeing what's coming, both in terms of preparing their organization to take advantage of it, but also getting in now allows them to steer those capabilities and what will exist. So those are the three real groups within industrial that we believe should be participating, and that we welcome to participate either by directly joining AVnu or by participating on our Industrial Advisory Council. I may lean on Rick or others to help on generally throughout AVnu who else should be joining the organization.
All right, Rick. Who else from your standpoint should be getting on board?
Yeah, I think in general, I think Todd really nailed it, because it comes down to, you see we've got all the Ethernet silicon companies. They came in early because they're making the silicon, right? And so they want to make sure that they're meeting the market needs. And then you've got people, like you said, who are making end equipment, and you have two different categories there. Those who want to really make sure and shape it, to shape how the market's going to work, because ultimately what this technology is in every market is depending on the people who get together as a community and say, this is how we want it to interoperate, this is what we want compliance to mean. And so people who really want to lead there and take the lead. And then we've got quite a few of solution providers who have joined now. This is something that's happened over the last, especially the last year, where we've got middleware people, we've got people who are doing other stack suppliers, things like that. And that's the overall, that shows there's an ecosystem that's there now where people can, either you're making end equipment, you're making silicon, or you're making middleware, but you've got a reason to be part of this ecosystem.
That makes a lot of sense. If someone is interested, Rick, how do they get a hold of AVnu to join up? Is it emailing you or calling you on your cell phone? How do they do it?
Yeah, exactly. So you can go to avnu.org, and there's all the information, membership information, tells you about the different levels, as well as contact details for administration, and they can guide you through the process for joining.
Okay, very good. All right, guys, we're going to wrap this up a little bit real quickly, and we'll ask all three of you kind of the same question. Paul, we'll start with you. What are some of the things, either from Cisco's point of view or from your point of view personally, that AVnu is geared toward or is poised to kind of break through, or some of the breakthroughs you're looking forward to in the next 6 months to a year?
The way we kind of see it is, we think of this as a pretty impressive innovation for standard networking, be able to pull in all these industrial and control applications, devices. It's going to be very valuable. And we saw a lot of value with 802.11 and the ability to do wireless communication with a lot of different type of end devices. But what really made 802.11 a widely adopted technology was the Wi-Fi Alliance went out and pulled the right parts of those standards together, put a little bit of glue on it, provided people with free stacks to run Wi-Fi, and put a bunch of additional things, security and some other things into that 802.11, and put together a certification regime that really, if you look at it now, well over 90% of the silicon that does 802.11 is Wi-Fi certified, and anything that has Wi-Fi in it, you have a lot of confidence in the end user community that the device with Wi-Fi in it is going to pop open the laptop and it's going to talk to any Wi-Fi network that's available, as long as the security requirements are that kind of interoperability is, and that drive of the marketplace is what we would hope AVnu can do for TSN and AVB. So, it doesn't happen overnight, but we see a lot of big potential here for AVnu for this technology.
Yeah, absolutely. All right, Todd, whether that's industrial or whatever, wherever else you see this going, what are some of the things that you're excited about for AVB over the next 6 months to a year?
Well, I think in general for industrial, I think it's coming into the scope of what our applications are, and I'll speak now specifically for National Instruments. As we look at this, the fact that we now have one converged network where we can do streaming for our measurement applications, we can do low latency data transfer for high accuracy control and things like motion control. We can do management on this. We can do data logging and file transfer, remote access. This converged network, incredibly high performance network where we are able to, because we are on standard Ethernet, scale gigabit and beyond. So 10 gig, 100 gigs, or 400 gig standard now in work. So bandwidth opens lots of options. Time synchronization of well under a microsecond between the nodes. This latency from node to node ordered in microseconds. This enables a lot of capabilities that we couldn't. And the final one, I guess I'll throw this one out. We don't have any of the and silicon vendors on, but we're also looking at this largely as being free because it is making its way into the Ethernet chipsets and the switch silicon that we would buy from the Intels and the Broadcoms and the Marvells and others. And as that makes its way in, we've classically seen in this Moore's Law style, we get great capability and we're able to get that at very good pricing because it makes its way into the general market. And so that's why we're so excited about the capabilities that are coming in, and we're counting on AVnu and on IEEE to help us deliver something that does meet those common foundation we can all build on.
So by free, you mean it's something you're already purchasing, and the silicon manufacturers are just going to start baking it in there?
Yeah, I can give an example that I think is okay. We use Intel chips in some of our products. As we started looking at this, we found that the latest Intel chip that we were using had many of these pre-standard capabilities already built in. And so that's an example of we get the capability without needing to invest, put down special hardware, pay extra for it.
Very good. All right, Rick, as we wrap up, what are some of the things that you're excited about next 6 months to a year as far as AVB?
Yeah, I think, obviously the launch of the new group, and we'll have a whole new community coming in, and that's going to push some things that we're going to be able to use in other groups. And so I'm excited about that because those tight control applications are something that even for something like a lighting control for Pro AV or for something like the automotive self-driving car, those are very exciting innovations that we're looking forward to, and it'll be led out of the industrial group originally. And then obviously we'll see quite an ecosystem of certified products in the Pro AV space, and our first certified automotive products. I mean, it's really taking some big jumps forward this year.
Right. And do you have timelines for the automotive ones as well?
Yeah, we'll open the certification middle of the year, and then we'll see how people's products go through those. Right, the first ones usually are a little bit rougher, but I'm feeling pretty good because we're building so much off the Pro A certification. They were able to use so much of that I think that's going to actually go pretty well. So we should see certified automotive things this next year.
And will the industrial products take the same path? Will you have a separate one for the industrial?
Yeah, every group has its own certification roadmap, right? And they have to bring in the features that make sense to them.
That makes sense. All right, that does it for this episode of the AVnu Alliance podcast. Gentlemen, thank you so much. Rick Kreifeldt, the AVnu Alliance president and chair. Todd Walter from National Instrument, he's the senior group manager. And Paul Didier, solutions architect, Internet of Everything, vertical solutions group from Cisco. My name is Tim Albright. Thank you so much for listening. Thank you so much for watching.